Record. All right, now we're recording, getting started, homework solutions, and our Zoom meeting. So first, does anyone have any general questions? No general questions? Yes, Seth, I see you.
I haven't done the homework problems.
Figures, okay.
You just put them out yesterday.
Right. We had the lesson yesterday, and then I posted the homework. So you watch the lesson, you do your homework, and then today you're prepared for class. Yes, exactly. All right. Well, if we don't have any questions, let's just mute our mics until you do have a question. That way you won't have any background noise. And we're going to start with this one. Another data set from the back of the book. A sample of 106 body temperatures with a mean of 98.20 Fahrenheit. Assume that sigma is known to be that. Consider a hypothesis test that uses a 0.05 significance level to test the claim that the mean body temperature is less than 98.6. So there we go. There's our claim that the mean body temperature of the population is less than 98.6. That's what we always start with. Our hypotheses, our null, and our alternative. The claim tells you what our null and alternative are. Now, last week we were talking about hypothesis testing for proportions. This week we're talking about hypothesis testing for means. So mu is going to be our statistic, our parameter. So we know that equality always goes in the null. So what does this say? Less than 98.6. That does not have equality in it. So it goes right here, less than 98.6. The opposite of less than is greater than or equal to. So it's greater than or equal to 98.6. Nice chin there, Sage. So start with that. Where's our claim? That's less than. Our claim is in the alternative. Okay. Now we need to get our information from the problem. N, 106. That's how many items are in our sample. Their mean, the mean of that sample is 98.2. The mean of a sample is x bar. Remember, the mean of a population is mu, the mean of a sample is x bar. And I guess for significant figure's sake, we should put the 0 there. Sigma is given to us. That's our population standard deviation as 0.62. Consider a hypothesis test that uses a 0.05 significance, so that's alpha. 0.05. And now we should have everything we need. Let's grab our formula from the formula sheet. That's geometry, sorry. Okay. So we're looking right here. Test statistics. These are the three we're going to be using. This week, right now, we're using a Z test statistic for the population mean, sigma known. So right here, this is what we need. So I'll stick that in here. So this is the only difference from last week, the formula for the test statistic. Everything else is exactly the same. We're still going to do a p-value test. We're still going to do a critical value test, the traditional method. So right now, all we need to do is find our test statistic. X bar, well, that's 98.20. Minus our mean, 98.6, our population mean. Over sigma, 0.62, divided by square root of n. And it was 106. So I'm going to type this in the calculator, and I suggest go ahead, take the time to actually write it down before you type it in the calculator. That way you can go back and see what you typed in wrong. So make sure you're in mode 1 on the Casios. 98.2 minus 98.6. Fraction in the denominator, 0.62 over square root of 106. And we get negative 6.64. Let me write that down. Negative 6.6, and then it was 423. For the test statistic, I like to go 4 decimal places. That way I'll be safe whether I use the traditional method or the p-value method. Either one will be fine with the 4 decimal places. I'll start with the traditional method, and then we'll do the p-value method. So for the traditional method, I need to look up my critical values. So I'm going to go ahead and sketch my curve. And we know our mean is in the middle. It's a left tail test. So I need to take alpha and look it up on the chart. You could also do an inverse norm. 0.05 on the chart is right here. For an alpha of 0.05, we have negative 1.645. It is a left tail, so I am going to use the negative. Negative 1.645. And my rejection region is over here on the left. Okay. Now I'm going to plot my test statistic. Well, that's negative 6.6. So it's fairly safe to say it's the left of that. Negative 6.64. So it is in the rejection region. So that means we reject the null. Not nil, null. Okay. If you wanted to get the critical value on the calculator, either one, you just do an inverse norm. So we're going to go to mode, down, 3, 3, type in our alpha value. And that gives us negative 1.645. The left tail, so we keep the negative. So if we just were doing the traditional method, we'd be done. Reject the null, claims in the alternative, we can make our statement after that. However, I'm also going to do the p-value method. And if I look up this negative 6.64 in the chart, I'm going to get something like 0.0001 because it's, it's definitely lower than negative 3.5. So for that, we just use 0.0001 from the chart. We can actually get a more accurate p-value from the calculator. And it is a left tail, so if you don't remember how to do it, there is a flow chart right above this page. The left tail, we find the area to the left of the test statistic. The standard normal distribution table gives us the area to the left of our z-score. Our test statistic is a z-score. This 0.001 is our p-value, 0.0001. And if I compare that, yeah, it's definitely less than 0.05. So again, if p is less than alpha, we reject the null. So we can also do this using the Casio. The p-value is the area to the left of our test statistic. Well, that means we need to do a normal CDF. So normal CDF, lower bound would be negative infinity. Upper bound would be our test statistic. And we can just go 2 decimal places. It's really not going to make a difference. Leave those alone. And we get a decimal followed by 10 zeros and then a 1, 5. So yeah, we have decimal 10 zeros. It's out there. It's less than any alpha you can want. Okay. So p is less than alpha. We reject the null. Our claim is the alternative. Use that chart I gave you. There is enough evidence, sure, to support the claim that the mean body temperature of the population is less than the mean body temperature of the population is less than 98.6. So that'd be our final conclusion. So if we look at it, we got the test statistic, we got the critical value, we got the p-value, we rejected the null, and then we wrote our final conclusion. If you're doing these on your own and it doesn't specify to use the p-value or the traditional method, you can do either one. You don't have to do both. You can do either the p-value or the traditional. If you're using a TI, I'd highly suggest the p-value since it gives it to you. TI users, we go to stat, tests. This week we're doing a z-test. And our input will be stats. We don't have a list of data here. Mu is 98.6. N, our sigma, is 0.62. And X bar is 98.2. And N is 106. Looking at our alternative, less than, so our tail is a left tail. There, so I'm going to click calculate. And we get our p-value and our test statistic instantly. Test statistic there, p-value there. Question? Let's see. How do you get p-out value with that? Exactly like we just did. To get the p-value without the calculator, you look it up. It's the area to the left of that test statistic. You can either use the chart or you can use the normal CDF. Either way will work. And excuse me for 1 minute. Oh, Heidi says, I'm in the meeting, but I can't hear anything. Can everyone else hear things?
I hear you.
Okay, Heidi, try turning the volume up on your
hear
computer,
you.
maybe. Okay. 1 second, baby's crying. Be right back. Yes, Alana's crying. Okay, I'm back. Let's see, 2 questions. Yes, can you show how to get the p-value on the chart? I'm so confused on that. You look up the test statistic on the chart. This is the test statistic. This is the chart. Negative 6.64 is less than negative 3.5. So that means it's 0.0001. It's a left tail. So all we need is the area.
Is the area to the left or the area to the right?
Yes, if we look, here's a pictorial representation of it. We have a left tail. Look right here. Alternative is less than. That makes us that means we have a left tail we're dealing with. That means we look up the area to the left of the test statistic. This is the test statistic. We need the area to the left of that. See this shaded part right here, that's what we need. That's what the chart gives us. So all we had to do is look up that number on the chart. Negative 6.64 is lower than negative 3.50, so it's right here, 0.0001. Welcome. So it depends on what kind of tail we're dealing with. We have a left tail, right tail, or two tail. And here's a pictorial representation of each situation. So if we had a right tail, after we looked up the number on the chart, let's say we had a right tail instead of 0.0001, to get the area to the right of it, since there's a whole 1 for the entire probability, we do 1 minus this value right here. So it would be 0.9999. That would be the area to the right. Hi, Alana.
If there's nothing to the right of it, you just minus 1.
No. To get the area to the right of any z-score. You look up the z-score on the chart, and whatever number you get, you do 1 minus that number.
So you can just use the positive z-score to get that also, though, right?
Well, it depends. If you already have a positive, then you'd use a negative, and vice versa.
I got you. So if it's a positive, if it was positive 6 point blah, it would have been. You could use the other chart to get that.
So
This is the same chart. This is not a different chart. This is
I know
all
what you
one chart.
mean. I know what you mean, but that one is used for negatives and the other one's used for positives. So if it would have been a positive 6 point something, we could have just got the right side by using the positive chart.
Yeah, do 1 minus. Just do it.
Okay, I got you.
What's the top row numbers for?
Okay, so if we need, let's say, negative 2.03, we look negative 2.0 right here, and then 0.03 is right here. So this would be the z-score corresponding to negative 2.03.
Okay.
That's the hundredths place right there.
All right. That makes a lot more sense.
Okay. Any other questions? Okay. Going to the next one. Oh, Heidi, can you hear us now?
She probably didn't join the audio, Mr. Swallow.
Let's see if she comes to us any time now. All right, let's go to the next one. So we have randomly selected statistics students of the Arthur participated in an experiment to test their ability to determine when 1 minute has passed. 40 students yielded a sample mean of 58.3 seconds. Assuming that the population standard deviation is 9.5 seconds, use a 0.05 significance level to test the claim that, and I'm just going to go ahead and highlight, the population mean is equal to 60 seconds. That's the claim. Based on the result, does there appear to be an overall perception of 1 minute that is reasonably accurate? Start with your alternative and null hypotheses. Reading the claim again, mean is equal to. Mean is equal to, that's going to be in the null, 60 seconds. That's my claim. The opposite of equal to is not equal to. All right, so again, we always look at our tail in the alternative. So this is a two tail. So now let's write down our information. N is 40 students. Let's see, sample mean, that's X bar, is 58.3. Sigma is 9.5. And alpha is 0.05. Okay, so there's our info, there's our hypotheses. Let's get that test statistic back. That's the formula. And let's plug in the numbers. So no matter which method you're using, you find the test statistic first. That's your first step. Well, after writing everything down. X bar, 58.3. Mu, 60. Sigma, 9.5. And N is 40. So again, we're going to just type that in the calculator. TI users, you can just type in all the info and it gives it to you. 58.3 minus 60 over fraction 9.5 over square root of 40. And I get that, sure, whatever, make that a decimal, negative 1.1318. For the p-value method, you really just need 2 decimal places. For critical value method, usually 3 is enough. Just go 4 to be safe. So round your test to 4 decimal places, and you're always gonna be good to go. So it doesn't specify. So let's just start the p-value on this one. So p-value, let's see, how do I do that? It's a 2-tail. Let me go to my chart, my flow chart up here. 2-tail. It's the left to the right. I don't know, let's look. So probably you already know that it is to the left, but let's draw it anyway. Let's see. Here's my mean. And I'll make it blue. Yeah, it's to the left of it. Yes, you can also draw my screen. Thanks for erasing that. Negative 1.13. So that's the test statistic. It is to the left of the center. The center is always 0. The center is always 0. It's negative, so it's to the left. You can also draw it and see it's to the left. Is the test statistic to the right or the left of the center? It's to the left. So we're going to do this. Twice the area to the left of the test statistic. We're going to find the area to the left of this and double it. Negative 1.13. Using the chart, negative 1.1, 1, 2, 3, 4, 3, right here. Here's the 0.03. Oh, I did that. Negative 1.13, right here. That's it, 0.1292. So what we do, let's see. Oh, twice. So we got to double that. So this times 2 will give me my p-value. So 0.1292 times 2. And it's 0.2584. So yeah. Alpha's 0.05. Let's see, which one's bigger? Oh, T's bigger. Fail to reject the null. P is greater than alpha, we fail to reject the null. Now we can also do it using the critical values. I do that one now. To get the critical values, I need to use my alpha. However, I have a 2-tail test. Anytime you have a 2-tail test, 2-tail, we have to chop alpha in half. There's got to be 0.05 in both tails put together. So instead of 0.05, I'm going to use that divided by 2. 0.05 divided by 2, because it's a 2-tail, is 0.025. So that's what I'm going to look up. Let's see, here's my chart down here. And I look for alpha inside the chart. 0.0, no, that's 00, that's not it. 0.02, oh, here it is, 0.025, exactly. So that's negative 1.96. My critical values, 2-tail, I have 2 of them. My critical values are negative 1.96 and positive 1.96. I put those on here. Well, that's to the left of that. So I'll put it right there and there. And I shade the tails always shade the tail, don't shade the middle. And I can see that, again, we're going to fail to reject the null because our test statistic is not in the rejection region. So traditional method also tells me to reject the null, or fail to reject the null. So you only do one of these 2 things. Whichever you choose is perfectly fine. Know how to do both because you'll have to do both. But for the majority of the problems, you can choose. Now, where was our claim? Our claim was in the null. We failed to reject the null, so we cannot reject the claim. There is not enough evidence to reject the claim that, and then we go back and read, the population mean is equal to 60 seconds. That's our claim. The population mean is equal to 60 seconds.
On the quiz, do we have to put any of the numbers in the answer or just the conclusion?
It depends on what the question asks. If it says perform the test, then you just perform the test and this is your answer right here. If it says give me the p-value, then you give me the p-value. If it says choose the correct curve sketch, you have to do this kind of thing.
Okay.
Okay.
Well, so the last one was asking for more, though, huh?
The last one was asking for more.
The last one had a bunch of questions under it.
Oh, well, this was basically walking you through the whole process step by step.
What I'm saying, do we have to put that in the answer?
No.
Okay.
Your answer for the test, if it doesn't specify, your answer is this statement right here. This is your answer.
Yeah.
However, instead of asking for you to perform the test, it might ask for the p-value. This would be the p-value.
All right.
It might ask you for the curve sketch. This would be the curve sketch. So you have to be able to do all these parts because you may be asked to give me this part, this part. If it doesn't specify, this is what you give me. If it says just perform the test, this is the answer. If it specifically says give me the p-value, this is the answer. If it specifically says find the curve sketch and it's 16 multiple choice answers, it's going to look like that.
All right.
Any other questions on this one? Doesn't look like it. Moving on. All right, so this one had data with it instead of just giving us the stats. So we actually have to find the mean of this data set. TI users and Casio users, you can just type this into your list and it'll give you the mean on the Casio. For TI users, you can just select this list. So let's see. Move it down a little bit. Psychologist claims that the mean age at which children start walking is at least 12.5 months. The following data gives the age at which 18 randomly selected children started walking. Walking ages are normally distributed with a standard deviation of 2.5 months. Test at the 5% significance level if the mean age at which children start walking is at least 12.5 months. So no difference. Start with your null and your alternative hypotheses. At least 12.5. The mean age at which children start walking is at least 12.5 months. That's our claim. So that's at least. That's greater than or equal to. That's in the null. That makes less than our alternative, which means we have a left tail test. Our tail always comes from the alternative. Doesn't matter what the where the claim is, doesn't matter what the claim is. It only matters what your alternative hypothesis is as far as your tail goes. Now let's write down our information. N is 18. We don't know X bar, but we do know sigma is 2.5. Alpha is 0.05. It's 5%, convert that percent to a decimal. Okay. Let's see, so we need X bar before we can calculate the test statistic. So I'll take the time, I'll do this on both calculators. It will take a minute. You could, of course, just add all these numbers up and divide by 18. That'll also get you the mean of age in months of these children. But if you want to use the Casio's table, the data set, you can type it in under mode, stat, and then you just hit one variable, 1. Type this information in, 15, 11, 13, 14, 15, 12, 15, 10.
Mode stat and what?
Mode stat 1.
Okay.
15, 10, so 16, 17, 14, 16, 2 15, 14, 11, and 13. I like to check and make sure I have the right number of numbers. 18 is how many numbers I have, and that's how many I should have. At least I know I didn't skip one or double one. So can't be sure I typed in everything correctly, but that's, if I had a number other than 18 here, I definitely typed something in wrong. After you type all that in, hit the AC button. If you notice right here, we're in stat mode. We're not in mode 1, we're in stat mode. So we can do statistics down here, shift stat. And what we need is a variable, number 4. X bar is what we need, number 2. That's 13.83 repeating. And I'm just going to save that for later. Shift store, how about A? In case I need it there as A now. I'm going to write it down here, 13.83. And really, I should round this to the 10th place. We go 1 decimal place past what the data has. So 13.8. Okay. So now we can calculate the test statistic. I'll go ahead and show TI users how to type all this in though. So if you're using a Casio and you haven't done your homework yet, why don't you take this opportunity to keep working this problem? There's your information. Calculate your test statistic real quick while I type in all this information again. So TI users, first thing I want to do is clear this list. Go to the top, clear, enter, done. And then move this over out of my way. 15, 15. Oh, why are you not typing? Oh, because it's in. Dang. 11, 13, 14, 15, 12, 15, 10, 16, 17, 14, 16, 13, 15, 15, 14, 11, 13. And I do have 18 numbers because this is 19 right here and it's blank, so that's good. Second mode to quit. Then I go to stat, go to test, run the Z test. Instead of stats, I'm going to select data. Then I just type in my information. The mu 12.5, population standard deviation or population mean. Alpha 2.5. List. I type my data in list 1. If you type it somewhere else, if you typed in list 2, you'd hit second 2, and that's list 2. Mine, however, is in second 1, list 1. Frequency will always be 1 for our class. And we look at our tail. It's a left tail, so we're good. Keep that highlighted. Calculate it. And it does give me the mean right here, 13.83. But it also gives me the test statistic and the p-value instantly as well. So if you are using a Casio and you calculate the test statistic, you should have gotten 2.26. I'll do that in just a second. But you can see right here your mean. 13.83 repeating. So now for the test statistic. Oops. CASTIO users, we're going to have to type in this formula. TI users, you're done. So let me, the X bar, we just calculated 13.8. I'm actually going to use that stored value that I got in my CASTIO instead of just 13.8. I'll just round at the end. Minus 12.5 over 2.5 over square root of 18. If I type that in, I will use this value here, go to mode 1, type in stuff, fraction button, and I'm going to hit alpha A. Well, let me just check and make sure I saved it. Oops, okay. Alpha A. Yeah, that's 13.83 repeating. So I'll type it in. A minus 12.5 over fraction 2.5 over square root of 18. Get that, and I get that, who really cares, 2.2627. 2.2627. Compare that to the TI.
I got 2.206.
Did you use 13.8 or did you use that whole decimal?
Yeah, I used 13.8. I didn't do the whole decimal. Why did you do the whole decimal?
I did 13.8.
Yeah.
Because it would be a compounded rounding error. I just don't like rounding.
So why did you
round? As far as the data is concerned, our X bar should be 13.8. However, we got a more precise number in the calculator. So when we're doing calculations, we're going to use that. We don't round until the end of the problem. So if I did use the 13.8, you should have gotten 2.21. That could actually make a difference on this problem. I'll see if it does or not.
It doesn't, but
yeah.
So do we have to use that decimal or no?
It's best if you don't round until the end of the problem. So store your whole data value in the calculator until you actually, get your final answer, this right here. So we'd have the 2.26.
Yeah, that makes sense. All right.
Well, I ain't gonna be able to do that A equals whatever you did.
Why not?
Because I didn't see how you did it.
Okay, it's really easy. You hit the shift button. Then you hit, you see that little RCL above 7?
Yeah.
You hit that, and then you pick a letter. How about F?
Okay.
Then you hit equals, and you can clear it out. And anytime you hit F in there, it's not going to be that number.
My answer for our mean.
The mean. Mm-hmm.
That's when I press it. I do.
Yeah,
shift,
that's when you do shift, store, letter equals. And that'll store it to that letter.
Let me try this. All right.
Okay. All right.
All right. Yeah,
So,
I got that.
Good. So that's a test statistic. We can do p-value method or traditional method from here. I did a p-value first. I'll do traditional method first this time. Curve sketch. Zeros right here. Let me get my critical value. I have a left tail. So alpha is 0.05. I just use the chart. Let's see, 0.05, that's negative 1.645. I do use the negative because it is a left tail. It's the left tail, we keep the negative. Right tail, positive. Two tail, both. And that's going to be over here, negative 1.645. And I shade that. That's my rejection region over here. And if I look at it, where the heck on the other side of the problem is my test statistic? So I'd say that's pretty much out of the rejection region there. It's way the heck over there. So yeah, we're gonna fail to reject the null there. That's the the traditional method using the critical value. P-value method, find your test statistic.
So we're
Go ahead.
We're not showing the right side.
No, our critical value is right here, negative 1.645. It's a left tail.
If it was,
That means,
so if it was two tails, we'd shade the right side.
well, if it was two tails, we'd also have the positive 1.645. You don't shade based on your test statistic. Your test statistic, you have to decide, is it inside the shaded region or not? So this thing was way the heck on the other side of the thing, way away from the shaded region. That's why we failed to reject the null. Now, if we would have had a two tail and we had that positive right there, then we would, then we'd reject the null because it would be in that shaded region.
Okay.
But since the left tail, we're shading to the left only. Right tail, we shade to the right only. Two tails, the only time you shade both ways. Where were we? Oh yeah, p-value. Left tail, let me see here. Left tail, area to the left of the test statistic. Okay, 2.26. That's positive, so 2.2. I think that's 6 right there. Yep. So my p-value is 9.881. .9881. Sorry, said that wrong. And let me think, which one's bigger? This or that bigger? I think P is bigger than alpha. So again, we're going to fail to reject the null. That's our initial conclusion. We fail to reject the null. You can get that either from the p-value method or from the traditional method. TI users, TI spits out the p-value for you, and it is slightly different, 0.9882 instead of 9881. But again, I take that error into consideration whenever I'm making the keys. So yeah, P is greater than alpha, fail to reject the null, claim is in the null. There is not enough evidence to reject the claim. So claim that. And what do they claim? That the mean age for walking was, at which students aren't walking, is at least 12.5 months. The mean age at which children start walking is at least 12.5 months. So this would be our final conclusion. That's it. That's the answer. If this were the problem on the test, if this were what the problem was looking like, I don't care about any of this. Down here, that's your answer. You got to remember though, a few of you were, well, a lot of you were making some mistakes with your hypotheses. You got to know what at least and at most means. If you can't draw that in symbols, you're screwed. So you got to be able to draw it. You got to know whether it goes in the null or the alternative. And you also have to know which one your claim is. All of that comes from this part I highlighted here. In fact, it comes from, no, I don't want to say. It comes from this right here, at least 12.5. That tells you everything you need about your hypotheses. At least 12.5, greater than or equal to, is in the null. That makes less than for the alternative. Claim is in the null. So if your claim's in the null, you better not have the word support in your answer. If the claim is in the null, we're either going to reject or not have enough evidence to reject. That's your option. Okay, any questions on that one? Okay. Let me see who we lost. Heidi. I guess she decided to leave. Let's see if we can invite her again. Oh, well. She could just join from the meeting ID. Anyway, next. So this one I made up with some Google Sheets fun. Is Google Sheets RNG really R? So is Google Sheets random number generator really random? So I generated 31 random numbers, 31 because I wanted to be greater than 30, because that's one of the requirements, between 0 and 30. We would expect their mean to be 15. You know, if you add up all the numbers between 0 and 30 and divide by 31, you get 15. Below are those numbers. Again, I just did a random number generator and that's what popped out. The mean of the data is 13.64. You're welcome. I didn't make you type all that in. I calculated the standard deviation of a huge random sample of random numbers between 0 and 30. It was like 700 numbers I just dragged down and found it to be 8.9. I did that like 5 times. It's between 8.8 and 9.1. So 8.9 it is. At the 5% significance level, test the claim that the mean is not 15. So let's see. We got our null. We got our alternative. What's what? Test the claim that the mean is not 15. So the mean of the population, I really should have said. Is not. Seth, what symbol is not?
The not equals, the equal sign with a line through it.
Yeah, there we go. So that does not have equality, so it goes in my alternative. And that's my claim. That's an I right there.
Wait, so there's
Go
no
ahead.
alternative?
This is the alternative, not equal to. Does not have equality, so it goes in the alternative. That means the null would be what?
I don't know.
What's the opposite of not equal to?
Equal to?
Yeah. So that's the null.
But why are we changing it up now?
We're not changing anything. We always have our alternative and our null hypotheses. We get where the claim is based on the problem. The mean is not 15. Is not 15 would have to go in the alternative because the not equal to doesn't have equality in it.
Because that's the only one that goes into the alternative.
The alternative never has equality in it. So it's either going to be strictly greater than, strictly less than, or not equal to. That's your 3 options for the alternative.
Okay.
For the null, your options are equal to, greater than or equal to, and less than or equal to. So those are your only options for the null, and those are your only options for the alternative. Our claim is not, that's going in the alternative. And n would be 31. N is 31. I was nice enough to give you X bar, 13.64. I calculated the standard deviation 8.9 for sigma. And we're going to use the 5% significance level, so 0.05 for alpha. So there's my move and all my information. Calculate the test statistic and go from there. So it's X bar minus the mean over, and then let's see, it's sigma over square root of n. And again, if you don't remember that, you don't have to. It's right there on your formula sheet, back top left corner. X bar minus mu over sigma over square root of n. X bar minus mu over sigma over square root of n. Type that in and see what pops out. Mode 1. 13.64 minus 15 over fraction 8.9 over square root of 31. And that gives me negative 0.8508. Okay. So that's my test statistic. From there, choose p-value or traditional method to find your answer. Why not p-value? So using the chart, I'm going to look up my tail first, see what's going on. So, two-tail. What do we do with a two-tail? Is it to the left or the right of the center? I don't know. Let me draw it in a different color. Well, my center is always 0. So negative 0.85 would be here-ish. Let me put it in red. Negative 0.85. So that's the left of my center. So if it's the left, I find the area to the left of the test statistic and double it. So I just need to look up this, negative 0.85. Negative 0.85 should be right here. So 0.1977. It's a two-tail, so after I do that, I have to double it. Point 1977 times 2 gives me that. Oops. 0.3954. So P is bigger than alpha. Since P is bigger than alpha, I'm going to fail to reject the null. We have a lot of those on this homework. Oops. And of course, you can also use the traditional method. We're going to find our critical values. So let's see, critical values. I just do them right here. To do that, we look at our tail, two-tail. Cut alpha in half. So I'm not going to look up 0.05, I'm going to look up half of that, 0.025. Did that earlier, it's 1.96. Right here, 0.025. Two-tail, alpha gets cut in half. So negative 1.96 and 1.96. And that's going to be out here and over there. Shade it. The test statistic is not in the critical region, so we fail to reject the null. So fail to reject the null. The claim is in the alternative. With the claim in the alternative, we're either going to support or there's not enough evidence to support. We're not going to reject it. Can't reject it. There is not enough evidence to support the claim that the mean is not 15. Done. Any questions on that one? Okay. I think it's the last one. It is. Okay. The Atkins diet, does it work? When 40 people used the Atkins diet for 1 year, their mean weight change was negative 2.1 pounds. Assume that the standard deviation of all such weight changes is 4.8 pounds, and use a 0.05 significance level to test the claim that the mean weight change is less than 0. So that's what we're going to test. Test the claim that. Bleh. That's what we're testing. That's what we need for our hypotheses. Less than 0. That's this symbol. That's going to go in the alternative. So mean is less than 0. Mean is greater than or equal to 0 for my null. The claim is right here, less than 0. All right. N 40. Their mean weight change, X bar, negative 2.1. That's right here. A bunch of blah, blah, blah we don't care about. Standard deviation, sigma is 4.8. Alpha, 0.05. So we got our info, we got our hypotheses. Let's find our test statistic. And again, TI users, you could just type this in and be done with it. Okay. Negative 2.1 minus 0 over 4.8 over square root of 40. Hang on. Let me see what my dog's doing. If we type that in the calculator, negative 2.1. Don't need a minus 0 because yeah, that's just gonna stay the same. 4.8 square root of 40. Negative 2.77. No, she's just screaming. No, she's fine. Negative 2.7670. There's my test statistic. From there, p-value, traditional method, your choice. I did p-value first, so I'll do traditional method first this time. 0. Critical values, let me grab those. It's a left tail. So I'm going to look up the 0.05. That's negative 1.645 for my critical value. And excuse me for 1 minute, I'll be right back. Sorry. Okay. Just wait till I'm done with this, my love. Okay. Now I'm back. Critical value negative 1.645. That's over here-ish. Shade to the left. And then my test statistic. Negative 2.77, that's over here, definitely in that shaded region. So we're going to reject the null. Okay. The test statistic is in the shaded region, that's the rejection region, means we reject the null. So from there, we could answer the question, but let's go ahead and do the p-value method.
So we can choose which method we want, the p-value or the traditional.
If it doesn't specify, it's up to you, because all I care about, if it doesn't specify anything else, is your conclusion right here.
But if it asks for like the critical value or the p-value, we have to find them.
Correct. If it specifically says, give me the p-value, you got to find the p-value. If it specifically says, which of these curve sketches matches, well, you're going to have to do the traditional method and match the curve sketch.
I think the p-value is easier.
Me too. Okay, let me see, p-value. I've only done this 152 times. I don't remember. Let me look at the flow chart here. Oh no, I just forgot. What's my tail? Left tail. Left tail. Area to the left of the test statistic. So that's what I'm going to do. I'm going to look up this number and find its area to the left, negative 2.77. Negative 2.77. That's right here. 0.0028. And another reason I like the p-value method is because I can see just how sure we are. Because remember, we're comparing this to alpha. So if it's just barely less than alpha, then it might be, if I use the lower significance, though, it's not going to work. But for this one, if I even use the alpha value of 0.01, it's still going to be less than alpha. So I'm pretty certain on this one. P is less than alpha, regardless of what kind of alpha you're looking at. That means I'm going to reject the null. And if I do that, I support the claim. Claim is less than 0. So there is enough evidence to support the claim that the mean weight loss was less than 0. Yay, it works. Yeah, close enough. I used slightly different words. Okay, so that's the answer to that question. But let's look at the actual significance. Based on the results, does the diet appear to be effective? Yeah, it works. It definitely has weight loss, but the mean weight change appear to be substantial enough to justify it. You're losing 2 pounds in a year. Yes, that's not happening. That's just crappy diet right there. It's not going to work for you. Sorry. Okay, so that would be the answer to those other questions. But again, on the test, this is what I'm going to be looking for. And remember, there's 4 options. You have to determine where the claim is, whether or not to reject the null, and then one of these 4 things is going to be your answer based on those 2 pieces of information. So this is what your answers are going to look like. Now, same thing exactly we did last week. Only difference we have is how we calculate the test statistics. But other than that, it's exactly the same process, finding the p-value or using the traditional method. Your choice, same way. So do we have any questions before we end this?
I think I'm good.
Okay. Do your homework. If you have trouble with the homework, send me some messages. Don't try and learn it while you're taking the quiz. Yes, I'm looking straight at you, Seth.
Yeah. No, this helped a lot though.
Good. I hope so.
Me too.
Let's see, we got a chat. Shots fired. All right, Miss Knoll, an alternative hypothesis mixer-upper. Lakin. Let's see. Yeah, we're talking about you. Anybody else? No? All right, guys. Well, that's it. Should be a easy week if you go ahead. Joey, do
What?
you have a question? No? Okay.
Want to see my daughter?
Yeah.
Sure. Mine's screaming her head off in the crib. Hello. What's the name again?
Violet.
Violet. Hello, Violet. You don't look very purple.
All right.
Okay, guys. Well,
All
I'm
right.
going to stop
See you later,
recording.
dog.
Bye, everybody.
Later.
And that'll be that.